The general aim of this course on urban transportation planning is to impart knowledge first to understand the mobility pattern in urban areas, second to understand the factors that influence the level of mobility in urban areas, the factors, particularly the causal factors that influence the mobility pattern in urban areas, third to develop relationships between the level of mobility and the causal factors, fourth to use this relationship to predict the future mobility pattern in urban areas, and fifth and final to use the predicted mobility pattern to understand the future requirements of transportation infrastructure to meet the future demand for transportation. Before getting into the details of the planning process, let us try to understand certain aspects related to transportation itself that are relevant to the subject of this study. For example, if you ask a question as to what is the basic purpose of transportation, the answer is this: the basic purpose of transportation is to provide efficient access to various activities that satisfy human needs. This is the definition or the answer to the question in a nutshell. Therefore, the general goal of transportation planning is to accommodate this need for mobility, isn't it? Within specific contexts, however, questions such as whose mobility, for what purpose, by what means, at what cost and to whom are not amenable to easy answers, or in other words, these are the questions to be answered when you get into the planning process in specific contexts. And contemporary responses or traditional answers to these questions are largely rooted in historical aspects related to transportation, as well as socio-economic characteristics of people living in urban areas, and have been influenced by many factors including technological innovations, very important and relevant for planning process, private interests and government policies. First, let us look into the technological innovations related to transportation first before going into the other relevant aspects. So, this is what we are going to see next: development of transport technology, historical aspects. And as you all know, transportation was recognized as a specialized area of study in a formal way only in the late 1950s. Hence, transportation as a subject of study is comparatively young compared to traditional streams of structural engineering, hydraulics, soil mechanics and so on. Transportation engineering is relatively a younger stream of study, and transportation as an activity of life process, however, is as old as civilization of humankind, because there is no activity without transportation process. Hence, it is appropriate to consider transportation as a process to be as old as human civilization. Hence, it is appropriate to study how the transport technology grew with the growth of civilization of humankind. Let us first look into what happened in the development of this technology in prehistoric period. As you all know, in the beginning people used their limbs, mainly foot, to move from place to place, mainly for two important purposes, namely food and shelter. So, foot was the only known mode of transportation at that point of time. Even today, as you know, foot is a very important mode of transportation, providing access to all other modes of transportation as well as egress from all the different types of modes that we use even today. And when they had heavy loads to be transported, when they gathered more food items to be transported to their shelter, they carried them on their back, shoulder or head, whichever way they found it to be more convenient, and they had their own way of packaging and fastening the goods to their body, to the shoulder and so on, and carried safely to the destination. And the next step was learning about carrying large quantities of goods by joining together in moving such large amount of goods, which led to the culture of group working by a set of people in goods transportation. And as you know, for carrying large quantities of goods, they need to have a kind of specialized containers. They made these containers using huge animal skins, fabricated in such a way that the skin can be tied onto large poles or wooden branches, and keeping the pole in a horizontal position, they loaded the material to be carried, and then 2 or 4 people on both sides carried this huge consignment of goods from one place to another. Just to give you an idea as to how this arrangement looked, this is how goods transportation was made using a device called litter, Litter, used for transport of goods. And a litter was also used then for passenger transportation, particularly for transporting elderly people, children and so on. Obviously, the pouch has to be modified to suit the requirements of human ergonomics, and they did that and used this modified litter for passenger transportation. And the litter used for passenger transportation looks like this. As you could see from the costume and other characteristics, this belongs to some Asian region, and Europeans at the same time had their own version of litter used for passenger transportation. Those litters look like this, better fabricated and finished, but the purpose is same, used for transporting elderly people and children from place to place. Then primitive people later learned how to teach animals to carry loads. Obviously, when they wanted to carry more loads, they thought, why not make use of animals, and donkeys and camels were mainly used for this purpose, because these animals are more convenient for this particular purpose. This is how goods transportation using donkeys were done, which was quite popular at that point of time, and camels used for goods transportation in certain parts of Asian countries as well as other parts of the world. When the terrain and weather conditions were conducive, like snow covered mountainous terrain, they used sleds, wheelless carts made by putting pieces of wood together, and used them in transporting goods and people. And sleds, as you know, was drawn by dogs, and this is how the sleds looked, which were used for transporting people as well as goods. This is a closer view of the same. This is terrain specific, as well as it can be used only under conditions where the whole terrain is covered with snow. People then discovered that travelling on water could be faster and easier than travelling on land, maybe by observing logs of wood being carried by jungle streams at a faster rate, they realized that using water as a mode of transportation may be more advantageous for faster and smoother movement. Probably a floating log might have served as the first boat for the people to move from place to place, just sitting over the log and moving around. An important discovery was made later when it was found that the wind could be harnessed and used as power to drive boats. They just had a feel of making use of wind as energy which can be harnessed for moving boats, but they did not get into the technical aspects of harnessing wind at that point of time. Now let us look into the developments in historic period before Christ. Some of the earliest civilizations, as you know, began in southwestern Asia and Egypt about 5,000 years ago. As people gathered together to live in groups in fixed locations, namely villages, agriculture, trade and manufacturing increased, and hence the need for transportation also grew. The pressing need for communities living in different parts for movement of people and goods in large quantities on ground, on the surface, made them to work hard to find a suitable means for movement between the community settlements, namely the villages. This resulted in an important invention which enhanced the transport technology to a significant extent. What is this important invention? Anybody? Yes, please. Yes, the invention of wheel. And the most important milestone in the history of transport technology development is the invention of wheel, no doubt about it. Historians disagree on the time of invention of wheel. The wheel was probably an adaptation of rollers or logs of wood which were found to be rolling on sloping terrain. The Sumerians, who lived in Western Asia about 3000 BC, may have been the first people to use the wheel. This is supposed to be the first version of wheel, just a log of wood cut to size with a hole made to insert an axle. This is the first version developed in 3500 BC. As you could see, this is quite heavy. The self weight of the wheel itself will make it difficult for the cars to roll on. So they felt there could be a possibility to improve this wheel. The main objective was to reduce the weight by slashing the portion which is not required, using thin planks and riveting them together, and using the fabricated circular disc as wheel. And the next stage of wheel development was providing reinforcement for the hole that is made at the center of the disc to carry the axle. You can see the reinforcement provided for the central portion. And the subsequent development was towards reduction of the weight of the wheel further. This was attempted by removing certain portion of the wooden material at the middle and having a kind of a rim and spokes. And the final form of the wheel took this shape, and this happened, which is similar to our conventional bullock cart wheel. This happened in 1500 BC. What is the time gap between the first and the last stage of the wheel development? 2000 years. Is it too long a period? In my opinion, it is not too long considering the technological advancement at that time. Okay. It is a reasonable time period which has enabled people to come to this stage in the development of wheel technology. The invention of wheel facilitated use of wheeled vehicles for transportation obviously, and hence the need for roads for smooth and fast movement of these vehicles arose. People started thinking about construction of roads because they had to use the wheel cars at a faster rate, making use of these roads. And of all the ancient people, the Romans were the finest road builders. Beginning in the 4th century BC, the Romans built smooth, hard surfaced roads wherever they ruled, from England to North Africa. This led to a very popular saying. What is a popular saying? Please put up a hand. Yes, all roads lead to Rome. Romans were experts in road construction technology at that point of time. Then let us look into the developments in historic period AD up to 10th century. Of course, progress in transportation came to a halt after the fall of the Roman Empire in the AD 400s. For the next several hundred years, during a period known as the Dark Ages, Europe was torn by wars which brought an end to the trade and commerce. The result of wars is end to or decrease in trade and commerce, which again results in decreased transportation activity. There were few developments in land transportation during this period until the rigid horse collar and iron horseshoes were invented in the 1900s. These two inventions greatly speeded up transportation on land. How do you think that these inventions would have speeded up land transportation? Invention of horseshoe and collar. Until then, they did not have a proper device to attach the animal to the cart, and there was no device available to facilitate the animals to walk over long distances. That is how these two inventions were really significant in land transportation at that point of time. This is what I mean, a device to attach the animal to the cart as well as the horseshoe etc. were invented at that point of time. Then let us see what happened from 10th to 16th century. The coach, which enabled groups of people to travel together, was invented in Hungary in the 1400s. Stagecoach service began in Europe in the 1600s. The stagecoach travelled a regular route, stopping at set points or stages to change horses and allow passengers to eat and rest. A mode of transportation which follows a regular route and stops at set points is termed as a public transportation mode. So, these stage coaches were nothing but public transport modes used at that point of time. Okay. These are the stage coaches, a two tired one, people travelling in stage coaches over long distances. There is simply a public transport vehicle used for transporting people. There were private transport coaches too. They were looking like this. Phoenicians travelled in their ships called galleys from the eastern Mediterranean to the British Isles on trading voyages. The Greeks too were great sea traders. When the Romans set out to conquer the world, they built a powerful fleet of galleys. The compass, first known to the Chinese, was probably used by Europeans for navigation around 1200 AD. This is how the galleys looked. The ship driven by human muscular power, and of course the two sails were not very helpful. It was mainly driven by human muscular power. These ships are named as galleys. Then the developments from 17th to 19th century. Let us first look into what happened in respect of non-motorized modes of transportation. Stagecoaches came into use in the American colonies around 1756 with the setting up of a stagecoach service between Philadelphia and New York. This was a regular stagecoach service operated in the US at that point of time. The Conestoga wagon, first built in Lancaster country, USA, for goods transport, came into use around 1750. These are again coaches built exclusively for transporting goods. The wagon was drawn by 2 or 6 horses or mules depending upon the load to be carried. By the 1840s, Americans developed a new type of sailing ship called a clipper ship. But as fast as they were, the clipper ships still depended on favorable winds and currents. The clipper ships look like this. Sails of different shapes and sizes used for moving the whole of the ship, and wind was the main energy used for moving the ship. Continuing with non-motorized modes of transport, Kirkpatrick Macmillan, a blacksmith from Scotland, invented the first bicycle with foot pedals in the 1830 to 1840s, but he never patented it, and hence his idea did not catch on. This implies that patenting an invention was a must. There had been a law which enabled every invention to be patented. Unless it is patented, it will not be acceptable for further production. That is how, even though bicycle was invented by Kirkpatrick and Macmillan way back in 1830 1840, it was not put into use, unfortunately. Later, a French father and son team of carriage makers, Perry and Ernest Micox, invented an improved version of bicycle in 1860s, about 20 years later in France, and they patented the invention, and that is how the bicycle technology caught on. And early tires for bicycles were wooden. Metal tires were an improvement later, and solid rubber tires were added subsequently. A chain with sprockets was added to the bicycle in the 1880s. Air-filled tires were also added in the 1880s. In the 1880s, they had a complete form of bicycle which can be used with air-filled tires. The bicycle invented at the early stage looked like this. In 1869, a huge front wheel with a very small rear wheel, seat almost resting on the mudguard of the front wheel, and handlebar very close to the seat, almost right above the front wheel axle. Could you imagine how a person can ride this kind of bicycle? But we should learn to understand this kind of technological development, and understanding, appreciating technological development is well known in Germany. For example, recently the invention of bicycle technology was appreciated and celebrated by this way in Germany. You can see the same version of bicycle used in procession near a gate which is very well known in the history of Germany, Brandenburg Gate in Berlin. Of course, this was published in the Hindu, our national newspaper, on August 17, 2008. Let us look into the developments in terms of motorized modes of transport during the same period, namely 17th to 19th century. For centuries, people had only their own energy, the strength of animals, the force of the wind and water currents to transport themselves and their supplies until 17th century. When the steam engine was invented by James Watt in the early part of 17th century, a great revolution in transportation began. We can consider this invention as a very important second milestone in transport technology development, the first important milestone being invention of the wheel. James Watt constructed a working model of steam propelled wagon like vehicle in 1781 in England, which was improved upon by several others in the subsequent periods. In 1787, John Fitch, an American inventor, built the first practical steamboat. In 1804, Richard Trevithick built the first steam locomotive to run on tracks. This means that the first application of steam engine was in waterway transportation. This was first used in a steamboat, then used in land transportation involving rail first and then road. The idea of railway trains soon caught on. In 1825, the first steam powered railroad for public service, the Stockton Darlington line, opened in England in 1825. And if you want to have a look at the shape of the train which was used for this service, this is the train which was running between the two cities. You can just look at the size of the wheels, the chimney system, engine and so on. Then for hundreds of years, people tried to think of ways to fly. There is no end to ambition to move faster and faster. In 1793, the Montgolfier brothers of France built the first balloons that could carry passengers. When it comes to air transportation, we remember always the Wright brothers who invented the aircraft. Even prior to that, again brothers from France first invented balloons which can carry people, using which one can fly. In the 1870s, the first ocean liners for passengers travel were built. These luxurious liners remained in service until air travel became popular in the 20th century. In those days, for international intercontinental travel, the only mode of transportation available was waterway transportation. That is how these luxury liners were very popular for international as well as intercontinental travel. The liners look like this, huge ones to accommodate thousands of passengers and large quantities of goods. Continuing with motorized modes of transportation, by 1885, two Germans, Gottlieb Daimler and Carl Benz, were making cars with gasoline driven engines, not steam, gasoline driven engines. Soon after this car appeared, other models were also introduced. During the early 1900s, cars were owned mainly by wealthy people. Obviously, the cars were very expensive, only wealthy people could own cars. Henry Ford of Detroit, Michigan in the US introduced a Model T car which most people could afford and soon became famous. People's car, which is quite cheap, can be afforded by a middle class person, was introduced by Henry Ford. In 1900, the Model T car looked like this, introduced by Henry Ford. I do not understand why it is named as Model T car. It looks like inverted letter T, capital letter T. That is the only connectivity I could get out of the shape of this car. Then the developments in 20th century. On December 17th, 1903, on the beach of Kitty Hawk, North Carolina, the Wright brothers made the world's first successful engine powered flight, and the airplane era had begun. December 17th, 1903. Let us look at the photograph taken at that time on the same day. I will just read out the footnote for this photograph. On December 17th, 1903, the Wright brothers make history as they first fly a powered aircraft with Orville Wright at the controls, that is in the aircraft. The aircraft stayed aloft for 12 seconds in the first attempt, covering a distance of only 120 feet. 3 more flights took place at Kitty Hawk, the same beach, that day, the longest lasting 59 seconds and covering 852 feet on the same day. Perseverance, okay, fighting for success, and achieved a significant progress on the same day, just from 12 seconds to 59 seconds and just from 120 feet to 852 feet of coverage. And the commercial version of aircraft was introduced in 1936. First commercial flight was introduced in 1936, named Douglas DC-3 was the model. First successful commercial airliner operated in 1936. This is about the history of transportation technology development in brief. In this historical background, let us try to understand the transportation and the related technology today. We will see the developments mode wise. Let us first take road transport technology today. I have just shown the different types of vehicles used for road transportation, starting from private vehicles like car, passenger public transport vehicle, buses, and then goods transportation vehicle. What is the maximum speed one can achieve using car today? At the global level?
140 kilometers per hour.
140 kilometers per hour.
It's way beyond that.
It is fine for Indian conditions. For example, in Germany, the speeds normally achieved ranges between 180 to 200 plus kilometers per hour. The reason being that there is no speed limit in the autobahns of Germany. So, generally you can understand that it is possible to move at a speed of 200 plus kilometers per hour in a private road transport vehicle like car. That is the level of transport technology development today as far as private transportation by road is concerned. Buses, even articulated buses, can reach a speed of 100 plus kilometers easily for commercial operation, provided the road condition is conducive for such speeds. It is quite common in developed countries, buses being operated in the speed ranges of 90 to 120 kilometers per hour. And another important aspect to be understood here is in terms of public transportation, the size of the vehicle is increasing even in road transportation. Look at the size of the trucks used for goods transportation, the number of axles and wheels. Even these heavy trucks maintain speeds of about 100 plus kilometers per hour on intercity roads. So, that is the technological development as far as road transportation is concerned today. Let us look into the development in rail transportation. What is the maximum speed that can be achieved by rail? 513 kilometers per hour. When was it achieved and where was it achieved?
Japan says some bullet trains.
It is a little higher value, and let me just start off from the German rail system, and then I will get back to you about the maximum speed that can be achieved by rail transportation. What you see here is the train in Deutsche Bahn, German rail system. The Köln-Frankfurt line, Köln is the name of the city near Bonn, the former capital of West Germany, has brought Deutsche Bahn, DB is Deutsche Bahn, to the top of the high speed league with trains capable of running at 330 kilometers per hour and a reduction in journey times from 2 hours 15 minutes to just over an hour for travel between these two cities, namely Köln and Frankfurt. This is a reality. In most countries, trains are operated at speeds of 300 plus kilometers today. The advantage of this kind of high speed trains is that over moderate and short distance intercity travels, train can be integrated with air transportation. To make this point clear, I will give an example. I attended a conference in Bonn in Germany in the year 2006. I travelled from Vienna to Bonn by rail. My return journey was by air from Köln to Frankfurt, then Frankfurt to Chennai. A few days before my date of return journey, I contacted the travel agent to get the ticket confirmed and get some additional details regarding the time of reporting and so on. At that time I was informed that I have to go to Cologne railway station for checking in my baggage and take a train to Frankfurt airport and then fly from Frankfurt to Chennai. I was surprised and annoyed to hear that an air traveller is asked to travel by train over a short stretch between Cologne and Frankfurt. Then I came to know that travel by train for this particular stretch is faster than air, considering door to door travel time, the access time, egress time, and the time required for reporting at the airport, and then time required to get out of the airport to your destination point, and so on. If you consider door to door travel time for this distance of 200 plus kilometers, train travel is faster than air travel. Then I was really happy and reported at Cologne railway station. My baggage was checked in at the railway station itself. The train started on time. When I entered the train, it was a pleasant surprise. It was so spacious, much bigger seats than normally you find in an aircraft, quite comfortable. The route was along the river Rhine from Cologne to Frankfurt. It was a pleasant ride. The journey time was just an hour and 10 minutes. When the train stopped at Frankfurt, I realized that I was inside Frankfurt airport. Train comes into the terminal building area, and I got out of the train, took an escalator, and directly get into the gate through which I have to get into the aircraft. So this implies that high speed trains facilitate really reduction of travel time when your travel time or when your travel involves different stretches involving both short and long stretches. And there are other developments. Recently, world's fastest rail link in China was introduced. This was a news item published in the national newspaper Hindu on 27/12/2009. The service between Wuhan, a metropolis in central China, and Guangzhou city, a business hub in the southern Guangdong province, was put into trial operation on December 9th, reaching a maximum speed of 394.2 kilometers per hour. 394.2 kilometers per hour. We are concerned with commercial operating speeds of different modes. Even though experimentally they would have tried with these modes at higher speeds, our concern is about commercial operating speeds. And commercial operating speed of this train is fixed as 350 kilometers per hour. And some of you would have heard about maglev technology used in rail transportation, magnetic levitation system, and the trains are called magnetically levitated trains. And a maglev train floats about 10 millimeters above the guideway on a magnetic field. It is propelled by guideway itself rather than an onboard engine by changing magnetic fields. There is no engine for maglev trains. The train is propelled by the guideway itself because of the embedded magnetic system in the guideway. Once the train is pulled into the next section, as you could see in the sketch on the right hand side, the magnetism switches so that the train is pulled on again. Positive, negative, north, south pole changes. The electromagnets run the length of the entire length of the guideway. That is one important thing to be understood. This implies that the system is quite expensive, complex, difficult to maintain, and can be used under very special conditions. The maglev system was first developed in Germany, and a demonstration piece of maglev train was run in Berlin for quite some time, and Germans found that this system may not be operated to be economically viable in Germany, and they were trying for markets outside Germany. In the process they fixed a country which can buy this technology and run trains on commercial basis. The name of the country is, could you guess?
China?
You are right, and the Chinese have bought the technology and they are running maglev trains today. This is a train. In January 2003, the world's first commercial maglev train was inaugurated in Shanghai, China. It links the new Shanghai Pudong International Airport to the center of Pudong on the eastern part of Shanghai. The system has a length of about 30 kilometers with maximum speed of about 440 kilometers per hour. It takes about 8 minutes to go from one end to the other, making it the fastest urban transit system in the whole of the world, or I would say even fastest rail transportation system in the whole of the world. 440 kilometers per hour, the commercial speed. And in July 2006, I happened to visit Shanghai for attending a conference. For travel from the airport to Pudong city center, I used the same system and found that it took exactly the same time to reach the city center from the airport. The train is quite comfortable. They have separate space for putting your baggages, and the information system is very good. The advantage enjoyed by this system here is it is a point to point service. There is no intermediate stop. That way, in spite of the complexity involved in the operation and maintenance of the system, they are able to operate the system successfully, and I was told that the system is operating in an economically viable way. I am still unable to believe, but considering the cost of travel by taxi from airport to Shanghai, I am partly convinced that system may be economically viable, at least for the air travelers. If you want to travel by taxi, it is quite expensive. The travel by this train was quite cheap. Development in waterway transportation. The development is mainly in the size of the vessels that are used for carrying freight as well as passengers. A very large ship, usually between 100,000 and 400,000 displacement tons, used for transporting oil and other liquids in large quantities. That is what is happening today. Bigger and bigger vessels to transport bulk commodities over long distances. Another important development in waterway transportation, as you could guess, is containerization of transportation, which has really revolutionized goods transportation process by all the three modes: roads, railways as well as waterway transportation. The benefit enjoyed by waterway transportation by containerization is considerably more compared to the benefits derived by this process by the other two modes, namely railways and roadways. Container ships being loaded at a port is shown here. The container ships can carry up to 15,000 containers, per ship, and it is a very complex process because the containers ought to be arranged in such a way that they are easy to be handled at a particular port at a particular point of time. Their destinations, time of arrivals, etc. are computerized, and there is a kind of operation research process going on in handling the containers and transporting and loading unloading of containers and so on. Even though it looks quite simple, the process is quite complex. When you take an overview of the container vessel, it looks like this. just containers stacked as matchboxes in thousands on huge vessels, and vessels being moved at a reasonable speed from one continent to another continent. Then in air transportation, as you know, the average journey speed in the case of commercial aircraft is about 1000 kilometers per hour today. Even though the instantaneous speeds could be slightly higher than this, the average speed is about 1000 kilometers per hour. And we enjoyed high speed air travel for some time. Some of you would have heard about Concorde aircraft, which was operated at a speed of 2000 plus kilometers per hour, and it was grounded in November 2003 due to commercial viability to some extent and technical reasons. There were some technical snags. The company was not willing to take risk, and even at that time the aircraft was operated between selected cities like Paris, London, Paris, New York, Paris, Toronto, and so on, where the terminal facilities were sufficient to handle this kind of aircraft. Today, unfortunately, Concorde is not being operated. So it is a history. We have touched air travel speed of 2000 plus kilometers earlier, now traveling at a speed of only 1000 plus kilometers per hour. And now we are in space age, and transport technology has extended over space, and a spacecraft is a device designed to operate beyond the surface of the earth in outer space. Spacecraft may either be unmanned or manned, as you know, and spacecrafts are designed for a variety of missions, as you know, which may include communication, earth observation, meteorology, planetary exploration, space tourism, and so on. The term spacecraft is also used to describe artificial satellites. And what is happening in spacecraft technology today? There is an interesting development that has taken place recently. International Space Station, ISS. ISS is an international collaboration involving the efforts of 16 countries, built to maintain a long-term human presence in outer space. What is the purpose? Providing platform for microgravity experimentation and serving as a first step to far-reaching space exploration later. And the 16 countries involved in this project are these, starting from Austrian Space Agency, Belgian Space Agency, Brazil, Britain, Canada, Spain, European Space Agency placed in Germany, French Space Agency, and German Aerospace Center again placed in Germany, Italian Space Agency, Japanese Space Agency, Netherlands, Norwegian Space Agency, Russia, then Spanish Space Agency, and Sweden is also involved in this project. What do they do with this project? They collaborate in providing expertise in the form of fabricating the spacecraft, providing personnel, and so on for the project. So basic objective is to just facilitate human presence in space over a long period of time and study the effect of microgravity on human life process and other related activities, which would lead to far-reaching consequences later to reach out to outer space far beyond what has been done so far. On the space station, the people learn how to live and work in space, how to build hardware that can survive and function for the years required to make the round trip voyage from Earth to Mars. So that is the immediate objective, okay, making the voyage from Earth to Mars. I think we have seen certain aspects related to the history of technological development related to transportation and then current state of art of transport technology. With this, we will close our discussion for today. To summarize, I would say that in the prehistoric period, the main mode of transportation used was foot of either humans or animals. Later, the invention of wheel revolutionized the transport technology, which led to operation of coaches on well laid out roads, and later the invention of steam engine, which is a very important milestone, revolutionized the transportation technology, facilitating faster movement by all the three modes: waterway, land transportation, as well as air transportation. And today transport technology has extended to our space to a very significant extent, and it is possible that with further development in transport technology, we reach out far into space to explore more and more for well-being of humans. With this, we will close for today. Thank you.